Hello, we're going to take a look at 3 more AP Calculus multiple choice questions. These are all going to be those dreaded which of the following statements must be true type of questions. The select all that apply questions. Those bane of the existence of calculus students type of questions. Here's the good thing. On the AP test, there is only going to be 1 or 2 of them, which that also means there is going to be at least 1 of them on your AP test on the multiple choice section. So let's go through and take a look at these. This says the graph of f prime, the derivative of the function f, is shown above. Which must be true? Okay, so first of all, if this is the graph of the derivative, a few things you know. You know that at the intercepts, that is a max or min. Max or min of f. Okay, so same here, max or min. And then you know at the max or min of your derivative, that is an inflection point for the original function. That's because right here, the slope is going from increasing to decreasing. So the slope of the original is changing from the slope is getting faster, and then the slope is starting to slow down. That's an inflection point. Here, the slope is going from a negative value to a positive value, which in fact means this would be a minimum value because the slope is going from negative to positive. That would be a minimum. So we got some basics, but then the best way to do these which of the following statements is just to take each point by point, and say yes or no. F has a relative minimum at x equals negative 3. So we go to negative 3, we see it's an intercept. So as we already stated, we know that is a max or min. And then we see it's going from decreasing to increasing, or the derivative is going from negative to positive. So we have something that looks like this on the original function. So yes, that is true. Point 2. The graph of f has a point of inflection at x equals negative 2. We go to x equals negative 2, we see this. It is not a max or min on our graph, so we're like, no, that does not work. It is a point of inflection on f prime, but it's not an inflection point on f, the original function. Point 3, the graph of f is concave down for x from 0 to 4. So for those x values, is that concave down? For a function to be concave down, that means its slope must be decreasing. So if the graph of the slope is in fact decreasing, it's going down here, that means it is in fact concave down there on the original function. So we see that 1 and 3 are the only correct ones. Therefore, our correct answer overall is E. Second one, for which of the following does the limit as x approaches infinity of f of x equals 0? This question can be really easy if you understand the rate of growth of different types of functions as x goes to infinity. And so that is one way to solve it. Looking at these, we have 3 different types of functions. ln of x, x to the 99th, and e to the x. Or generally a logarithmic function, a polynomial function, and an exponential function. Rates of growth. The fastest growing function is going to be e to the x. Second fastest is a polynomial. Third fastest, or as some people like to call that, the slowest, is your natural log function. Now these rates of growth apply as x goes to infinity. Because interestingly, x to the 99th is going to be a higher growth rate all the way until x is around like 700. So e to the 700th is slower than 700 to the 99th, or less value. But eventually, around that 700 point, e does overtake x to the 99th. So in other words, to simplify this, your exponential is always going to grow faster than your polynomial function eventually. And then both of those are always going to be faster than the natural log function. That makes it easy because then if we're letting x go to infinity, we can look at each of these quotients and think, okay, between natural log x and x to the 99th, which reaches infinity first, in quotes? The bottom will, x to the 99th, because it grows faster. So while natural log is still going to be some number, the bottom is going to reach infinity, and you know if you divide by infinity, you're going to equal 0. So that means this does in fact equal 0. On the second one, which of these has a faster growth rate? E to the x does. So it's going to hit infinity while natural log is still puttering around being some normal number. Well, infinity divided by any number is still infinity. So that does not work. On the third one, we're comparing the polynomial with the exponential. And since the exponential grows faster, it's going to reach infinity first. And the polynomial is joining along with its slow friend, the logarithm, and still being a number. And when you divide a number by infinity, you get 0. So 1 and 3 are the only correct answers. There is another way to think about this if you forget that rate of growth idea. And the way to think about that is you can do L'Hopital's. If I apply L'Hopital's to the top, I'm going to get 1 over x over 99x to the 98th. L'Hopital's does apply in this because you get infinity over infinity when you plug in. In this case, you're like, okay, how does that help me? Well, notice I can keep applying L'Hopital's here, and eventually the bottom's going to become just a constant because by the power rule, this power is going to keep decreasing and decreasing. So pretty soon I'm going to have just a number down here, and then when I plug in infinity here, it's going to be 1 divided by infinity, which is 0. So I'm going to end up with 0 divided by a number, which is just 0. When I apply L'Hopital's on the second one, I end up with e to the x divided by 1 over x. Now when I plug in infinity here, I get e to the infinity over 1 divided by infinity, which is e to the infinity divided by something approaching 0. So I have something approaching infinity divided by something approaching 0, gives me 0 overall. On the last one, when I apply L'Hopital's, I get 99 times x to the 98th over e to the x. Same reasoning applies. If I keep applying L'Hopital's, I will eventually have a number up top and e to the x will be remaining strong on the bottom. Therefore, when I eventually plug in infinity, I will just have some number up top divided by e to the infinity. So a number divided by something really big is going to be 0. So you can apply L'Hopital's thinking with it, but based on my messy work there, you see it does take a little bit more work. Whereas if you can remember your rates of growth, it's a piece of cake. Lastly, and this is the easiest of the three, we have a limit type of question. If you see a picture like this where they have a piecewise function, just a lot of straight lines with holes in the graph, you should thank the stars because this is an easy question. It's just evaluating if you know what left-hand limits and right-hand limits mean and how to evaluate them. Okay, so it says look at the graph of the function, which of the following are true. The limit as x approaches 2 from the left is equal to f of 2. Well, the limit as it approaches 2 from the left is equal to -1, because that is the y value it's approaching. And notice how the hole is filled in at -1, so that means when I go f of 2 and evaluate it, I get -1. So -1 equals -1. Check. The limit as x approaches 6 from the left, so right there, that is approaching -1 as well, is equal to the limit as it approaches 6 from the right. Hey, they are both approaching the same y value. It doesn't matter that the function is not in fact defined there because of the open circle, but the limit does in fact equal -1 from both sides. What about the limit as x approaches 6 of f of x? So not from the left or from the right, but from both sides. That means from both sides it has to approach the same value for it to exist. And as we saw in the previous one, it does in fact approach the same value of -1. But what is f of 6? So I go to x equals 6. What is the y value? -3. Because they have defined it, they had filled in the dot down at -3. So it does not equal. So only 1 and 2 are true. Therefore, the correct answer is C.